Hello everyone. In this video I am going to demonstrate an application of Modbus over Ethernet. I am using UDP protocol to transfer the packets. So as you can see here, this is my Arduino Uno board. My board is connected with this Ethernet cable. This is my Ethernet cable. And the Ethernet cable is connected with the Ethernet port in my laptop. As you can see, this is the USB to Ethernet converter. So Ethernet cable is connected to my laptop for a communication between laptop and the Ethernet board. Now here in this case I could have used this network switch for this packet transfer, but I am not using a network switch. I am just connecting it directly in a same LAN. So physically my Ethernet port is on 192.168.1.177 IP, and this my laptop is on 192.168.1.17 IP. So both are on the same network. So that's why I am not using any network switch. I am directly connecting them so that they can communicate with each other. So now here you can see the Arduino Uno, and you can see the pin number 8 LED is on. See here, this pin number 8 LED is on. So I am using Modbus communication to control this Arduino Uno. So before going to the software, let us discuss the Modbus frame for a short while. As you can see here, this is the Modbus frame. So this is the Modbus ascii frame. So basically this Modbus frame is getting transferred over the UDP network, UDP, over the Ethernet UDP protocol. Okay, so you can see here, this is Modbus ascii frame. The command starts with a colon, 06 is the target Arduino address, 05 is the write coil, force coil command, 05, 00 and 08 is the address. See the coil address, 00 and 08 is the coil address. Okay, so 0008 is the address. So this is 08 corresponds to the Arduino Uno pin number 8. So it is, I am using here directly like this, 08. So 00FF is the command for low and FFFF is the command for high. And there are two checksum bytes here. There are two checksum bytes here. These bytes are used for error checking. So these are for the LRC check basically. So this is how the Modbus frame is. So I am going to transfer this Modbus frame over the Ethernet connection. So as you can see here, I am using a packet sender software. So you can see here, this is my ASCII data. So this is the data I am going to send. So this is the data I am going to send. Here you can see 06 is the IP, is the Arduino address, 05 is the write coil command, 0008 is the target coil address, FFFF means this has to glow. The LED has to be switched on, the command for on, and EE is the LRC code. So here I am going to select the protocol as a UDP. You can see here, this is the protocol is UDP. So okay, I am using a delay of 10 seconds, and this is the, you can see here, this is the Arduino IP address 192.168.1.177. This is the target address. So this is the address of my Arduino Uno, and you can see here this port number is 8888. I am using this port. So the data will travel through with this IP address and the port data. Okay, so now if I click send, the data will be sent to the Arduino Uno. So I have clicked send. So you can see here that I have clicked the send. Okay, so I have clicked the send data. See, I have clicked the send data. I have sent a data. So this data has gone to the Arduino Uno. Okay. So this data has gone to the Arduino Uno. I can see the record here. So now I am going to show you the Arduino Uno behavior. So I'd like to show you the timestamp here because I want to correlate the same timestamp on the Arduino program. So this is 6:05, 48 seconds. I have sent a data to the Arduino Uno. So now when I will go to Arduino Uno, I will see on the same timestamp there will be a received signal. So as we can see here, this is my serial monitor feedback. This I used for diagnostic purposes. So you can see here, see 6:05, 48 seconds, packet of data is received from my laptop 192.168.1.17, port is 53862. So I have received a packet of data from my laptop at this time. See, I have received a packet of data at this time. So what I have received? I have received to do this activity. So it is 06 means the Arduino address, 05 is the write coil command, 0008 is to is for the port number 8, the Arduino pin 8, for the Arduino pin 8, and FFFF is for Arduino pin switch on. So FFFF, as we have seen here before, that FFFF means we need to force the coil to high status, and EE is the checksum. So you can see here the data has been analyzed and it has triggered the pin number 8 to on. So this is how it is behaving. Okay, now I will show you the Arduino program where the IP address of the Arduino is defined. Now if you look into the Arduino program, see, this is the IP address of the Arduino 192.168.1.177 and the port is 8888. You have remembered, I think you have remembered that I have targeted this IP address with this port from the network scanner. I will show you again. See, from the packet sender software, what was my IP address? 192.168.1.177 with the port number 8888. See again, this is the IP address 192.168.1.177 and this is the port. Port is 8888. So you can see the same in the Arduino Uno. See, the same is mentioned here. So this is the target IP address. Okay, so packet sender has targeted this IP address with this port number and data is received here. See, it has received, and who has sent the data? 192.168.1.17. That is my laptop address. Okay, with this port. And what we have received, that I have already discussed, and it has triggered the pin number 8 on. So now I am going to switch off the pin number 8. I will give a command to switch off the pin number 8. So as you can see here, instead of FFFF, I am going to give 0000. Okay, so now I am going to send this data. So what I am going to do, I am going to send it. You can see here. So I have sent this data. Okay, so this data has been sent. So 6:11, this data has been sent. Okay, so now I am going to see the board conditions. You can see on the board the LED is off. That means the board has received the signal. Now I will go to the Arduino Uno and see what has happened in the Arduino Uno. Now watch the timestamp 6:11. It is the same timestamp I have sent the data. Received a packet of size 15. So this is the packet size from the IP address, my laptop 192.168.1.17 from this port. What did I send? I sent here the same address with all the values here 0000. So the same I have received, and it has analyzed the data and it has triggered the pin number 8 of Arduino to off condition. So this is how the circuit has worked. So basically I can say here the Arduino board is working as a client. So I am giving a signal to the client and the client is behaving accordingly. So like this we can send data using UDP, raw data packet between the client and the server. Okay, thanks a lot. Thanks for watching.